Hello students, and welcome to this video on logarithmic functions. Our objective today is that we will analyze the attributes of logarithmic functions using journal notes and practice 7-5 attributes of logarithmic functions. So last time you guys learned about what the inverse of an exponential function is, and the name of that is the logarithm. So a logarithmic function is just what we call the inverse function of an exponential function. Just like before when we talked about the inverse of x squared, right? If we have f of x is equal to x squared, the inverse f negative 1 of x of that would be the square root of x. So they had different names, they had different functions, but they canceled each other out. This idea of an inverse, something that will undo something else. So let's talk about going from an exponent to a logarithm and back again. So if we have some exponent, right, let's say that we just have an exponent y is equal to b to the x, right? And I want to convert that into a logarithm. What I'm going to see is that we just shuffle around all of our positions, right? This y, this expression says what happens when you take some number to the x power. The logarithm answers the question, what exponent do I need of base b to get y? So what we'll see is that you take your y, it becomes your input, the b goes down here into the base, and then the x will move and become the output. So the x and y have kind of switched places here, and then we've also got our b moving around as well. So let's look at a quick example. So let's say that I say 2 to the 5 is equal to 32. To rewrite this as a logarithm, what I'd say is something of log base 2 of 32 is equal to 5. So this is saying that 2 to the power of 5 is 32. This is saying that in base 2, 32 is equal to 5. Or, in other words, 2 to the 5th power will give me 32, or I could say, well, I have 32 and I'm kind of wondering what power of 2 I would have to take to get there. And that's going to be 5. And that seems a little trivial right here, but what if we had something that wasn't so obvious? What if I had something like 2 to the x power is equal to, let's just say, 193, right? That's obviously not going to be an exact answer, so that's where the logarithm comes in handy, is that I can answer this question when I use a logarithm. So I can say log base 2 of 193 is equal to x. So I can actually evaluate this now, and that's a really powerful tool for me to be able to have. All right, so let's talk about graphing logarithms. Last time, you guys actually graphed them, and you saw that they were just an inverse of some exponential function. So what we'll find is that that's exactly what we want to do. So first, what you want to do is you want to convert this into an exponent. So what that means is that you're going to say, well, your b, right, that becomes your b to the x power is equal to y. I apologize, that's b to the y power is equal to x. So you want to convert it into something like this, make a table, and then graph from the inverse of the table. All right, so let's go ahead and look at some examples of that. So let's just make a base. So we have 2, and I want to say 2 to the... We'll say over here that this is y is equal to log base 2 of x. Correct? Correct. So now, to be able to graph that, first I want to convert it over here. I want to say 2 to the y is equal to x, right? And now we're just going to do this normally. So we're going to kind of change our variables here a little bit to be more standard. So this is my inverse, so I can go ahead and say 2 to the x is equal to y. So I can graph that. I know that I'll have a point here, and then 1, 2, 3, 4, a point here, and I'll have a function like this. So then when I go to actually graph my logarithm here, it'll look like this. I'll transform all those points. So 0, 1 becomes 1, 0, and then 1, 2 becomes 2, 1, and so on and so forth. So I'll create my logarithm here. So this is going to be my answer. But you see, I had to create the graph of the exponent first, and then I had to go and find the log. All right, so something important about logarithms here is that if you have a naked log like this, this is actually called a log base 10 of x. So if you see something like this where it's a naked log, where there's no base down here, it is automatically assumed to be base 10. Your calculators will also work in base 10. So if you see log x, you can also throw it in your calculator and it'll be very quick. So first we have to convert this into the exponent form. So that's going to be 10 to the x is equal to y. So we graph that, so we have one point here, then we also have another point way up here, and then we have one, and then that's 1/10 already right here, so we can have that. And then remember, we need to transform it across this line. We need to take the inverse, and then that'll be my final answer. So my log now will be at 1, 0, and then it will go up increasingly like that, and then it'll be like so. And the attributes of this are that your asymptote is equal to x equals 0. Your domain will be x is greater than 0, and your range will be all real numbers. All right, so let's look at some others. So log base 2 of x, that's going to become 2y is equal to 2x. So again, we have our points. 1, 2, 3, 4. And we graph our original function. And now we have to transform it, aka take the inverse. And you'll get a point here, a point here, a point here, 1, 2, 3, 4, up 2. I'm sorry, this point is actually supposed to be right here. So we get a nice curve. All right. And again, you have your asymptote is at x equals 0, your range and domain. Your domain is x is greater than 0, and your range is all real numbers. All right, go ahead and do these next two examples on your own. I'll go ahead and transform them. So you have 5 to the x is equal to y, and then you have 3 to the x is equal to y over here. All right, so go ahead and do those now. All right, so once you're done with those examples, move on to your reflection. And your reflection is how are logarithms related to exponential functions? Once you're done with that, go ahead and go on to assignment 7-5, attributes of logarithmic functions. Have a wonderful day. I'll talk to you later.